Good evening, everyone. Um, Welcome back to the Nexus Research Academy class. This is class 6 of the series where we'll be talking about the, practical version of data analysis. So I am glad to have you all back again. My name is Dr. Obianuju Moalu. I'm the Executive Director of this academy, and together with my deputy, Dr. Divine Ewim, we are glad to bring this series to you. So I'll just quickly introduce the speaker for those who were not here the last class. Please, can I be heard? Great. So the speaker is Dr. Kekeocha Martins, a medical doctor, a research and business analyst who is dedicated to discovering insights for clinical research and businesses. He earned his medical degree from Koyuth in 2024, graduating with distinctions, and currently practices as a physician while actively engaging in research analysis. Dr. Kekeocha serves as the co-founder of Hidden Leaf Data Analytics and has co-authored 2 peer-reviewed publications in high-impact journals, with additional works in progress and under peer review. So, with our emojis and gestures, can we welcome Dr. Martins Kekeocha to the platform?
Thank you very much. Thank you very much. I'm very glad to be among your midst this evening to talk about the practical aspect of data analysis using SPSS. So we are going to go on straight up into how you get yourself used to the software, how to move about the windows in the software and all whatnot. Okay, so I'll first like us to just get accustomed to how questionnaire come about, how you transfer your data from a questionnaire into a spreadsheet on SPSS, because most times our data analysis starts from giving out your research as your questionnaire as your method of survey, how you want to get your data. So most of the times we use either a hard copy questionnaire which will be printed out or a Google form. But using a hard copy questionnaire, for example, we have a research on mental health status and social support among medical students. So this questionnaire is divided into different sections, section A, B, C, and D. Yeah. So coming over to this section A, we have the first question item. I would like to just call them question items. So you have the first question item, which is gender. So under gender, you have male, female, and others. Then you have age, you have year of study, you have marital status. So this particular questionnaire, this particular copy was given to a participant in the research to fill. So these are the responses gotten from one participant. So under age, under gender, you have female. Under age, you have 19. Under year of study, you have 4th year. Under marital status, you have single. Now, to make it easy for you in questionnaire analysis, you can decide to record all these things using numbers, and it's better for you to be systematic, so you already have it at your fingertips without having to recall so much. So most times what we do is that for each question item, we number the options from 1 to as much as it can be. For example, under gender, we can say, oh, males will be identified as 1, females will be identified as 2, others will be identified as 3. Now, under these others, you have to specify. So you can eventually still make a separate column for, oh, people that choose others. You put 3. Then by the side, you specify their gender. Then under age, you can just write 19. Then for year of study, we can make fourth year to be number 1, fifth year to be number 2, sixth year to number 3. So looking at the questionnaire, you already know the number to put in. Same thing with marital status, single number 1, married number 2, as the case may be. So you keep on going that way. So going over to the SPSS, I would like to use this data set for an example. So this is what SPSS looks like. So you have, using that same questionnaire, you have the column for gender, age, just ignore the second age. You have year of study, you have marital status, same thing we saw in the questionnaire. So this window you are looking at right now is called the data view. And if you look down here, you see that it's written data view. So it shows you this is where you'll be entering the data. Now, if you come over to variable view, this is where you like put in a background information of what your data should look like. So under gender, remember I said we want to be entering them with numbers. So here is to tell you, you choose the type of variable you are going to be entering here. If it's a number, you choose numeric. If it's a categorical variable or variables that are in words, example, single, you want to type single by yourself instead of using numbers, you have to change it to string. So that is what you do under this variable type. This type means variable type is obviously written here. So you choose OK. Then the next important thing is you can decide to write on your label. So this label is more like giving us more information on what this gender is, just gender. So you can as gender. So under label you have gender. But there are times when, for example, I can under this year of study, I can just decide to write level under this name, under this number 4. I can decide to just write level. So one might go through it and be like, oh, I don't really understand what you mean by level. Most times you don't have the liberty to write long sentences at this beginning part of your variable under the name of the variable. So you come to the label to write a detailed information about what that variable means. So I can write label on this side, then come over to label and say, oh, this is year of study. But here is already written year of study and anybody can understand what it means. So the next thing now is to go over to values. So for example, I told you that we can decide that 1 should be male, 2 should be female. So that is what you come under your value label to do. So this is how you just go about it. You type in 1, you type what you want it to be, male, you add it here. It will not add because there's already male in the labels there. So let's say you want to add 3 as others, you change here to others and you add it, it goes in there. So when I go over to my data view, once I put in 3 is automatically going to mean others. So that is what you do in this value side of your variable view. Then going over to measure, this is where those different levels of measurement come into play. We learned the nominal, we learned ordinal, we learned interval and ratio. Now, if you come to this measure, you have nominal, ordinal, and scale. All qualitative or quantitative variables, you put them under scale. You don't divide them into interval or ratio. So, for example, gender has 2 categories, which is male and female, and there is no order between it, like I explained in the previous class. So the measure here is going to be nominal, because ordinal is when the categories have to be placed in rank. Please, Vivian, can you put off your mic? So ordinal is when the categories are in a rank. So gender, you have male and female, there is no rank, so we just choose nominal as the measurement or the level, the scale of measurement. Same thing with age. Age is a number which is numeric. So the measure has to be in scale. You can't choose ordinal, you can't choose nominal. You have to choose scale. Going over to year of study, you have ordinal. Now, under this year of study, we saw fourth year, fifth year, and sixth year. And you know, sixth year is higher than fifth year is higher than fourth year. So there is a ranking. So now you have to choose ordinal as your measurement or your scale of measurement or your level of measurement. So that is what you do under this particular place. So that is for the variable view. Then going back to the data view, you can switch what you are seeing here into numbers and letters. You can toggle between these A. A means you want it to be in words. 1 means you want them to be in number. So when I was working on this data set, I used numbers. So this was what it looked like initially. But because in my value label, I specified what 1 means under gender. I specified what 1 means under year of study. I specified what 2 means under marital status. If I change it to words, it's going to automatically translate to that. So you can look at it in this way. You can look at it in this way. So to make it easier, I enter them with numbers. Then I give them the value label, so it's easier to understand and it works faster that way. So that's what I think I can say about the interface. I'm very sure I should have explained it very well. But in case you have a question, you can put it down in the meantime. So we'll go over to the next thing. We have descriptive statistics. Those are among the things we did on Saturday. So under descriptive statistics, for example, we want to check the descriptive statistics for the ages of these participants. So we go over to analyze. Under analyze, is already written here. You have descriptive statistics. You choose frequency. You can also choose descriptives. You can choose frequency. Now, when you choose these frequencies, you have to move the age over to the variable side because this is what you want to analyze. If you want descriptive statistics for also year of study, you put it over to this side. So you add what you want to analyze on this side. Then you click OK. But before we click OK, we'll have to check some of the things you can see here. So under here, you have statistics. Now for age, you can decide to check the 25% quota, 50% quota, 75% quota of our age. So you can click quota. There is mean. You choose what you want to see for yourself. There is median, there is mode, there is sum, there is standard deviation, there is minimum, maximum, there is range, there is variance. Anything at all you want to see, you put it. I'll also choose this skewness and I'll explain something about it. So continue. These are the statistics I want to see. If you want SPSS to also give us in chart form, they can give us bar charts too and express them in frequencies or in percentage, depending on what you want. Put continue. Then once you've chosen all what you want to be displayed, you click OK. Now, SPSS takes you to the output part. If you look at here, it's written output. This is where you visualize what you've chosen from your data side. So it visualizes everything here. You look at it and you get a hang of it. So we chose age and year of study. So under age, we have our average age, which is the mean, to be 28.8168. You have your median, you have the mode, you have the standard deviation, you have the variance, you have the skewness, you have standard of error, you have the range. Now, if you look at it, maximum minus minimum gives you range. So 31 minus nothing gives you 12 to show you that it's correct. These are the quartiles that we checked. So 25% quartile, 50% quartile, 75% quartile. I'm very sure that we will not have the luxury to explain in details what this quartiles mean, but I feel you can read it up and you understand what it actually says. Same thing with the year of study. So I'm going to talk about this skewness right now. So skewness just tells you whether the data has normal distribution or not. Now, when the skewness is in a positive value, that means that data is positively skewed. But if it's in a negative value, which is not what you have here, that means it's negatively skewed. But if our skewness is giving us 1, that means our data has normal distribution. So we choose frequency table. So this is your frequency table. How many times 19, age of 19 appeared? How many times the age of 20 appeared? This is the frequency, this is the percentage. So same thing with year of study. You get all these outputs here. So this is a bar chart representing 19 years, 20 years, and all what you have. So looking at this data, looking at this data, from what I said about the skewness, I told you that this age is obviously positively skewed. If you look at it, most of the ages are towards the left side of this axis, this age axis. But it's positive in the sense that most of the outliers are on the positive side of the axis. So you talk about negative or positive, negatively skewed based on where the outliers are located. If the outliers are located by your right hand side, that means they are positively skewed. Using like a number line, this is zero in a number line. If you go towards the right, you are going positively. If you are going towards the left, you are going negatively. So when your outliers are mostly towards the right hand side of the x-axis, you have a positively skewed data, which is what the skewness told us. Same thing with the year of study. You find out that most of the 500 and 600 are on the right side compared to where 500 is located. So that is for descriptive statistics. Another way to see an accurate an accurate histogram showing this, I think we'll be able to get a curve from there. I think we'll be able to get a curve. Let me check. Check. So under analyze, you have descriptive, yes. Explore. No, this is not going to this. So from looking at this, we can get that already. I don't know if I can see. If I can see histogram. Okay, you choose histogram. So I got here the same place, descriptive frequency under charts. You want to see the distribution curve for your age, you choose histogram. Then you click show normal curve. So once you click continue and open, you get your distribution curve. So this is still that same histogram telling us the same thing. You find the outliers towards the right side of your graph to show you that it's positively skewed. Same thing with this one. You have much of the data towards the right hand side, and that is what this value tells us, 0.84, which is positive. Same thing with 0.55. So that's for descriptive statistics. Then after descriptive statistics, we talked about the inferential, because under descriptive we talked about measures of center tendency, which is mean, mode, median, which I've showed you people here. We talked about measures of spread such as range, standard deviation, all of them are on this table. So you can get these values there. Then going over to inferential statistics, we talked about the estimation theory and the hypothesis testing. Now, under estimation theory, we talked about point estimation using a single value to make an inference. So an example we used was using the mean age that you get from a sample. So for example, now we get a mean age of 22.816 from this research that we've done, from this questionnaire that we've entered there. So we can now infer that the average age of students in this school, which is Gregory University, Abia State, is 22.816. So we've made an inference from a single point. That is point estimation. Then going over to confidence interval estimation using your confidence interval.
Hello, Chief, your mic is muted.
Wait, Dr. Divine, yeah, I know my mic is muted. It was intentional. Yes. Once I'm ready to speak, I'll unmute it. Okay, sorry for the break. Um, Going over to the interval estimation, if you come over to descriptive statistics, you come to explore. Yes, let's use the age for an example. So we have age. So when you come to the statistics, there is a confidence interval for the mean, which is 95%. So let's choose that and see what is going to give us. So statistics, yes. Okay. So now we have our 95% confidence interval for this mean. So for our point estimation, we said since the mean age is 28.816, our interval estimation can now be that 95% of our values, this 95% confidence interval for this mean means that, let's say for example that we have 100 students in Gregory University, Abia State, and we took just 10 people and we sampled them, made the research, and we got this mean age to be 22.816. Let me come again. Let's say in Gregory University, Abia State, we have 10 students, we have 100 students in total. That is the population. But for our sample, we took only 10. And we calculated the average and we got 22.816. 95% confidence means that if you once you've taken your first 10 sample, you got this 22.816. If you take another sample and calculate their age, and you get the mean age and you drop it, collect another 10 people, do it. So you are going to have a total of 10 groups in total, Abi, which is 10 times 10, 100. If you bring those 10 mean ages, there's 95% of them are going to fall within this 22.5 to 23.10. That's what it means. Everything might not fall within them, but 95% of them, maybe let's say 8 out of 10, they are going to have the mean falling within this value. That is what interval estimation means using the confidence interval. So I think that should be well explained now. But in case you have any question, you can still ask me later on. Please just focus on it at any time. But you can still draw my attention, I guess so I can go back. Then going over to our hypothesis testing, we started with one sample t-test. Now, in our one sample t-test, let me know if I can pull up this slide. In our one sample t-test, we are talking about comparing the mean of a sample mean to the population mean, trying to see if there is a significant difference between a sample mean and population mean. One sample t-test, I don't know if everybody can see my screen. One sample t-test compares the sample mean with a population mean. Example, weight measurement from a sample of 30 persons. So coming over to SPSS, we want to know if the mean age for this our sample is significantly different from any population want to guess. So we come over to analyze. You go to compare means, which is what you are doing. There is one sample t-test. Now we are dealing with age. Now you come over to here, we say test value. Test value just means what is the population mean you are trying to compare it with. Let's say you want to choose 30, you put in 30. You put in 30. There's a confidence interval. So you choose OK. So it gives us an output. So this is your one sample t-test. So your mean age is 22.816, yes. Your test value is 30. This is your standard deviation. Now, you have a table for your sample t-test. Now, for this t just means your sample mean 22 minus 30, which is 8 point something or 7 point something thereabout, divided by the standard error of the mean. That is how you get t. You can still check that up later. You see that it corresponds to it. So the important things you need to note here is that you check for this value, this significance for two-tailed, the value under there. For here, we are seeing 0.005. So in statistics, mostly, we always use less than 0.05. So all of us here can agree that 0.000 is less than 0.05. So that means that this mean 22.816 is is significantly different from our population mean, which is 30 years of age. That is what it means. So to further confirm this, you can also use your confidence interval. How can you use it? It's important for you to know that if your confidence interval contains 0, that means this mean is not significant. But if it does not contain 0, that means it's significant. Let me come again. If your confidence interval contains 0, what I mean by containing 0 is that if you draw a number line, -7 to -6 is on one side of the number line. It has not crossed 0. But if you have something like -7 and 2.4, that means you move from -7, cross over 0 before you get to 2. So here, our confidence interval does not contain 0. That means this population mean is significantly different from this sample mean is significantly different from the population mean, which is 30. So our value here for the significance has told us that, and the confidence interval has further gone to confirm that you hardly get instances where they contradict each other. Most of the times they always align with each other. So we'll go over to the next one, which is the independent sample. Okay, we'll go over to the next one, which is the PET t-test. So in PET t-test, you are trying to assess if there's a difference between two paired measurements. For example, weight measurement from the same subject in a nutrition program. So from one person, we are getting 2 readings. So it's a pair of readings for one person. So each person has a pair of readings. So coming over to SPSS, we are going to use this systolic blood pressure. Under here, you have systolic blood pressure and systolic blood pressure 2. I don't know if you can all see this very well. Let me adjust it. So let's say this is the first reading, while this one is the second reading. We want to know if there's a significant difference between this first reading and this second reading. And both of them are numerical variables. Let's say this was a patient's BP on admission, then was administered an antihypertensive. This is now their new reading. So we want to know if there's a significant difference. So we'll go over to analyze. We'll go to compare means. There is PET sample t-test. So here we look for the 2 readings, which is blood pressure. This is the first one. Then you choose the second one, which you are comparing it with. You want something. So we choose the first measurement, which is this. So that is variable number 1. You choose the second one. We can also compare for these 2 ages to know if they are significantly different. Just to make an example. So you click OK. Then these are the tables you see. So here it tells you that for the first pair, this is the average blood pressure for the first pair of people. This is the average for the second pair. Same thing, this is the average for the first pair of age. This is the mean. This is the mean for the second pair of ages. These are their standard deviation. Now we'll now go over to the main thing that we want to get from here. So In this place in particular, you can read from here blood pressure of systolic, which is the first measurement against the second one. So the first measurement against the second one. So the important things to look out for here is you can first come to the significant value. So if you see here, you get 0.15, which is less than 0.05. So there is a significant difference between the two measurements. Same thing with the first age and the second age. You have 0.000, which is less than 0.05. So there's a significant difference. To further confirm this, you come to the confidence interval and you see that the confidence interval here does not also contain zero. They are on the same side of the number line. So it further tells us that there's a significant difference between the mean of the first blood pressure and the mean of the second blood pressure. Same thing with the ages, the mean age of the first pair and the mean age of the second reading. So there's a significant difference. That is for paired sample T test. So if we go over to independent sample T test, or two sample T tests, we have two pairs of measurements from a group of infants that have like different qualities. For example, the weight of infants that were breastfed and weight of infants that were not breastfed. So you have weight in your measurement. Then this weight is now further classified based on were you breastfed or not. That's what you have to understand. There is something differentiating these two groups. Here, they are a pair, but here there is something differentiating these two groups. There is an exposure differentiating the two groups. So now coming over to SPSS, we want to use, for example, the age is what we want to know if there is a difference between age. Now, our differentiating factor now will be gender. The gender now is either male or female. So we want to know if there is a difference between the average age of people that are males and average age of people that are females, because now there is a differentiating factor. So they are unpaired, they are independent of each other. Males are independent of females. So we'll go over to analyze. You go to compare means. You choose independent sample T test. So starting from the beginning, our test variable is age. Then our grouping variable, what is differentiating this age, is gender, because our gender is either male or female, and there are only two categories. So we move gender over to the grouping variable. Then you see that right here, you can't click OK because you have to define the groups. So you click on define groups. So under group 1, remember when we're entering the gender, we choose 1 or 2 as our numbers. So under group 1, you can just put 1. Under group 2, you can put 2. You can switch it, but you just have to remember whether your group 1 was 2 or group 1 was 1, anyhow you want to put it. So you can switch it. So you choose continue. Now the OK becomes live, so you can click OK to go on. So when you click OK, you have your statistics out for you. So people that are male, which is 23.5 whatever. The mean age for people that are females, which is 22.4. It has told you that, okay, look at what is happening between them. Now, how can you interpret this table? There are two things you have to look out for. There is equal variances assumed and equal variances not assumed. So wherever you have your F, the row where you have your F to be located is the row that you keep on reading throughout. I'll just have to just speed up, but eventually you get used to all these things. You don't need to understand everything, but you need to grab one or two things. So the row where you have your F, that is what you are going to read. If this 2.069 was down here, we will read this second row continuously. But since it's here, we are going to continue with this first row. So coming over to this side, we have our significant value to be 0.000, which is less than 0.05. So what this tries to tell us is that there is actually a significant difference between the mean age of males and the mean age of female. That is what it's trying to tell us. Then if you go over to the confidence interval too, you see that everything does, both of them don't contain zero. 0.515 is on the same side of the number line as 1.7. They are on the positive side, so it does not contain zero. This is to further tell us that, oh, there's a significant difference between the mean age of males and females. So that is for independent sample t-test. Then we'll go over to ANOVA. Now, for ANOVA, I'll go over to the slide to read what we talked about ANOVA. So in ANOVA, we are trying to compare the mean between 3 or more groups. When we are doing independent sample t-test, we used 2 groups, which is, when I mean 2 groups, there are 2 categorical variables, which is male and female. But in ANOVA, you can do 3 or more categories. For example, trimester of pregnancy. You have first trimester, second trimester, third trimester. So our differentiating factor is now trimester. So an example that I'm going to use in our explanation here, I have under analyze, I have compare means. Okay, I think I'll first go with this. Okay, under our trimester, we have a column for trimester, yes. So under trimester, we have best time to start antenatal, which is divided into trimester, yes. So we have first trimester, second trimester, third trimester. So now we want to check what is the difference between the mean age of people that booked in first trimester, people that booked in second trimester, people that booked in third trimester. Is there any significant difference between them? So we go over to compare means, we choose ANOVA. Now in ANOVA, we choose age as our dependent list. Then our factor will be best time to start ANC. You move it into factor. Yes, I don't think there's any other thing you need to choose. So you click on OK. Output, you have your trimesters. First trimester, second trimester, third trimester. Then under the ANOVA, same thing here. You come to the significant value. Under here, we have 0.986, which is very, very, very greater than 0.05. So there is no significant difference between people that booked in first trimester, second trimester, third trimester. I'm just using this as an example. This might not be the exact variables that you have in your own research, but this is what's applicable. You are trying to compare the means between 3 different groups. Because it's 3 different groups, you have to choose ANOVA. But if you are choosing just 2 groups, you can use independent sample t-test. Then after ANOVA, we can go over to chi-square. Most of us are already familiar with chi-square. So in chi-square, you are checking for association between categorical variables. Example, level of education against booking of pregnancy. Maybe you want to know whether people with higher education level book earlier and whatnot. So for example, if you go under, yes, descriptive statistics, you choose for chi-square. It's not written chi-square entirely. So you go under cross tabulation. Now under cross tabulation, you can choose the age to be in. Okay, we are talking about categorical variables, yes. So best time to start ANC, let's place it under the rows. Then you have year of study under the column. It can be the other way around. Just there is no fixed way of doing it. It can be the other way around. So we've chosen rows and columns. We go over to statistics. You choose chi-square. You can choose correlation. Let's just put correlation here. So continue. Under cells, you have row. This is going to give us their percentage. I'm going to also explain something under this percentage. Then you have you click OK for the chi-square. Now, what this first trimester is, okay, I'm going to stop after this chi-square. So what this table is trying to tell us that The number of people that booked, the number of people in 400 level that booked at first trimester is 78. The number of people that booked under 500 level in first trimester is 41. That is what this table is trying to tell us. You continue like that. Same thing, second trimester under 400, you have 11. This is calculation in percentage. So if you move down, you have your values. So here you have Pearson's chi-square. This is your chi-square value. Under this place value, you have 9.38. So your chi-square value is 9.38. Why your p-value is 0.0, you can put significant, though it's close to the significant value, but it's not statistically significant. So that is for chi-square. Yes. Another thing I wanted to talk about was the Fisher's exact. Now, Fisher's exact states that if you draw your contingency table and you have any of these frequencies, 78, 41, 23, or 9, 8, 5, if you have anyone that is less than 5, you have to choose Fisher's exact, no longer chi-square. So if you're looking at this, you don't have anyone that is less than 5, so you have to go on with the chi-square. So to choose the Fisher's exact is choose the Fisher's exact. Trying to look for one. Okay, I don't know. I don't know if this my version of SPSS will show it, but Fisher's exact is just written here exact. So you just click it exact, simple, and you click OK. So you just report see Fisher's exact test. So you are just reporting this value 9.674. That's what to do for Fisher's exact. So I guess I'll stop here for the questions. Thank you for listening so far. I'm very grateful. So the questions can come in.
Thank you, Dr. Martins, for that detailed and wonderful presentation. I really hope we're all following. And we also have a YouTube channel that we can post the video so that in case you miss something and you want to go back to it, the YouTube channel is always available for you. But thank you so much. I tried my best to follow along, and I was able to grab some information regarding this. So, do we have questions for our speaker tonight? If we do, please, I need a show of hands. Anybody? Any questions?
Very much for the presentation. Please, my question is, when you were talking about set the confidence interval, we have the lower limit of the range and then the upper limit. I really didn't understand how to set the limit, how we arrived at that lower limits. Is how do we calculate, how do we get to the lower limit of the range? And how do we get the upper limit of the range? That's where I'm confused. Thank you.
Okay. Can you remind
Dr.
me
Martin, did you get that question?
Now, I don't know if you can be a little bit specific. Is it at the interval estimation side, or was it?
Yes, the interval estimation. Is an interval where you have the lower limits and then you have the upper limits. Then within that, that's where you have your mean. You understand? So I want to know how you're able to. Now you get the mean, and then you want to get the lower limit and then the upper limit. I really don't know how, to go about that.
I can be able to does not show you how to calculate it, but there is a formula. There is a formula for calculating confidence interval. There's a formula for calculating confidence interval. I don't know if I can pull up. It has a formula. I don't know how I can show. For each confidence interval, there is 95% confidence interval, there is 68% confidence interval. It has a formula. Yeah, it's not on this one. Please just give me some time with the presentation. So I don't know if you can see my screen.
Yes, I can.
And this is the formula. Confidence interval equals to x. This x is your mean. This z is a fixed value, which is 9.6. So for 95% confidence interval, the value for z is 1.96. You have your standard deviation. That means after calculating your mean, you have to calculate for your standard deviation. Then n is your sample size. Let's say, for example, here we use 100 adults. So 100 is the n. So you calculate the standard deviation. You put it into that equation. Same thing with x. X is now your mean. So if you want to compare it with, let's say, what we have here, if you want to compare it with what you have here, 1.6. So you have your x using this formula, plus or minus 1.96. In brackets, standard deviation, they will give us our standard deviation as 2.1. Then n, our sample size here is 202. So you put 202. If you do that in your calculation, like if you put it in a calculator, it will give you these two values here. So coming over to this slide, you have 120 plus or minus whatever you get from this calculation. So when you plus it, you have 121.96, which is your upper limit. Then when you subtract it from 120, you have 118.04. So using these values in this place now, in this my SPSS output, and if you use this formula using 1.96, you get this upper limit and lower limit. You can try it yourself and see. Probably when you get the video. I don't know if that explains your question.
Yes, that explains it. Thank you.
Welcome. You're welcome.
All right, thank you, Juliet, for that question. Do we have any other questions? Any questions, comments, contributions? All right, so in the absence of questions, I think we can call it a day. Thank you, Dr. Martins Kekeocha, for this absolutely detailed classes you've held. The first class on, variables, how to choose tests and all that. The second class on how to actually use SPSS, which is a problem that a lot of us have with data analysis. Dr. Martins, you're amazing for giving us this lecture. We appreciate you and thank you. Thank you. I think we can all
I'm very grateful.
disperse. We'll get the links to the YouTube video through our emails. All right, see you all in the next class.